Alright, so now let's do some examples with this. So if we're told that secant of theta is greater than 0 and cotangent of theta is less than 0, in which quadrant does the terminal side of theta lie? So think about it, write down your answer, unpause it when you want to check your answer. Okay, so hopefully you came up with quadrant 4. If you didn't, then this is my thought process. Well, first I ask myself, where is secant going to be positive? Well, a secant of theta is r over x. R is always positive because it's the radius. X is positive in the first and fourth quadrants. Okay, cotangent is x over y. What's going to make cotangent negative if they have opposite signs? So where are x and y opposite signs? That's going to be in the second and the fourth quadrant. So both of them have the fourth quadrant in common, therefore it's the fourth quadrant. Okay, another example. So if you're given the point -5, -12, I want you to find the sine, the cosine, and the tangent of theta. So pause the video, find those answers, unpause when you're ready to check. Okay, so hopefully you got the sine of theta is -12/13, the cosine of theta is -5/13, the tangent of theta is 12/5. If you didn't, or if you're confused, or if you just want to hear this lovely explanation, here's how I got that. So first I drew the point -5, -12. That's down here. Now I created a triangle from that. So I know, remember that these are locations, not distances. So this is -5. This side is -12. The hypotenuse is always positive. That's 13. This giant angle here is theta. So what I'm actually using is theta prime. But the sine of theta and the sine of theta prime are going to be the same. So the sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent. Alright, now another example. So if you're given that 3y plus 2x equals 0 is the terminal side in quadrant 4, I want you to find all 6 trig functions of beta. So go ahead and pause the video and do that. If you're confused on how to start, draw a picture. This right here is going to be the equation of a line. So pause, unpause when you're ready to check. Okay, so here you can see I drew the picture. So this is the equation of the line, y equals -2/3 x. So I have a slope of -2/3, a y-intercept of 0. So that's this line. From that line, I got the point 3, -2. And then then I drew this triangle. The hypotenuse is going to be √13. This angle here in blue is beta, so I'm actually using beta prime. And then here I have the sine of beta is -2√13/13. The cosecant of beta is -√13/2. The cosine of beta is 3√13/13. The secant of beta is √13/3. The tangent of beta is -2/3. The cotangent of beta is -3/2. Hopefully I did all of that correct. But those are our answers for the 6 trig functions of beta. The other key thing in the problem was that it had to tell us that we're in quadrant 4, otherwise this problem could have been in quadrant 2 as well, and that's going to change some of these answers. Okay, another example. So given that the cosecant of theta is 4 and the cotangent of theta is less than 0, I want you to find the cosine of theta and the tangent of theta. So again, pause the video and come back when you have an answer. A hint here is think first about what quadrant this has to be in based on this information, then draw your triangle. Okay, so here what I want to recognize is cosecant of theta is 4. So what I noticed then from that is that cosecant is positive, cotangent is negative. What quadrant is this in? If cosecant is positive and cotangent is negative, it has to be in the second quadrant. So now I draw a triangle in the second quadrant, and I know if cosecant of theta is 4, then the hypotenuse is 4, the opposite is 1, or some ratio of that. I could make this 8 and this 2. It doesn't matter, it just has to be a ratio of, when I divide the hypotenuse by the opposite, I end up with just 4. From the Pythagorean theorem, this side is going to be the square root of 15, but I know it's negative because this is negative in the x direction, and remember this is giving me a location of this point. Here's theta prime, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Don't forget to rationalize. Okay, just a couple more examples. So here, find cosecant of theta that given that the cosine of theta is -4/5 and theta lies in quadrant 3. So pause the video and unpause when you're ready. So here we should end up with the cosecant of theta is -5/3. So if I know cosine is -4/5 and I'm in quadrant 3, my triangle is going to look something like this. This side is negative 4, this is positive 5, this has to be negative 3. I know cosecant's negative 5/3. Alright, last example. So here, without using a calculator, I want you to find theta in both radians and degrees between 0 and 360. So this is what we did the other day. So for cosecant of theta equals negative root 2, cosine of theta equals 1, secant of theta equals 2, tangent of theta equals negative root 3, and sine of theta equals 0, and cotangent of theta equals negative 1. So pause the video and find theta for those within these restrictions. Unpause when you're ready to check. Okay, so hopefully I did this correctly. For cosecant of theta equals negative root 2, we should get 225 degrees, which is 5 pi fourths, and 315 degrees, which is 7 pi fourths. For cosine of theta equals 1, that only occurs at 0 degrees and 0 radians. For secant of theta equals 2, that's at 60 degrees, which is pi thirds, and 300 degrees, which is 5 pi thirds. Tangent of theta equals negative root 3 is at 120 degrees, which is 2 pi thirds, and 300 degrees, which is 5 pi thirds. Sine of theta equals 0 at 0 degrees and 0 radians, 180 degrees, and pi. Cotangent of theta equals negative 1 at 135 degrees, which is 3 pi fourths, and 315 degrees, which is 7 pi fourths. Okay, so to conclude, we want to make sure we understand a reference angle. It's a positive acute angle between the terminal side and the horizontal axis. A quadrant angle is an angle where the terminal side falls on an axis, and we want to be able to find trig functions of any angle.